when we talk about energy, we always don't think about electric. Okay, but the source of the electrical energy comes from still the biggest at this moment is based on petroleum. Okay, it is still based on fossil fuel. Yeah, that generate the electrical energy. So can you live without electric? Can't. Can you live without internet? We can't. Okay. So green energy is almost like number one business now. Okay. Of course, food security is very important because we need food, we need clean water, we need medical, we need under food. The theme is called food security, meaning that sustainable of food supply. That, but we almost forgot that it can be one day because the population in the earth is getting higher and higher. So we might be competing for food and clean water one day. But in order to sustain all this, okay, uh, it's actually the energy. So it's the one that can help us to sustain food security and clean water is actually energy. Okay, right. So because of sustainable chemistry, very important for us to take care of Earth. Okay, so energy from petroleum, from biofuel, is known as, I would say, uh, polluting the Earth and our environment with excess of CO2. And then we know about the climate issue, global heat, right? So the weather is ridiculously sometimes unpredictable. All right. So this is due to climate change. Okay. So some people don't believe in climate change, but it is real. I mean, what we have experienced recently or for many years, we have flood, excessive flood. We have uh, sometimes extreme heat. So it's something that's looks what I would say, it's not like I have experience when I was still a child. When I still a child, it's not that hot in Malaysia. I can still sleep without AC, without aircon. Okay, but now it's a necessity. So the climate change or the heat is actually uh, real, and this is part of contribution from fossil fuel. Okay, because of the production of CO2. So when we talk about green energy, right, of course, there are certain characteristics that the green energy should fall into. Um, the energy should be generated from renewable, environmentally friendly resources. Okay, unlike fossil fuels, which is petroleum, which pollutes the environment. Okay, we know that already with CO2, production of CO2. Green energy should be able to reduce the greenhouse gases. And this green energy is essential for combating climate change, the one I mentioned just now, and ensuring a sustainable future because we need to save the world. We need to save the earth. Okay, so lower carbon emission helps slow global warming. So everybody has heard about global warming. The temperature of the earth is increasing. So this one, whether you accept it or you don't want to accept it, but it is happening and we have experienced the outcome of this global warming. Okay, less air and water pollution. Yeah, definitely. because of the fossil fuel, reduces dependence on imported fossil fuel. In some of us, fossil fuel is main income, created jobs in renewable energy sectors, of course. New initiative will initiate new jobs. So types of green energy resources, solar energy, common, which is quite common, because some of us might have start uh, building or uh, putting that infrastructure at your home, adding solar cell to your home to reduce the electricity bill. So solar energy is very common, especially for us. We have throughout the year sunlight. Okay, that's an advantage. Okay. Wind energy, yeah, there's a lot of wind energy being utilized in certain parts of the world. Hydropower, so if we have enough resources for hydropower that can generate electric. Biomass energy, so the energy can be generated from waste, for example, palm oil waste and other waste as well. Okay, but I think there are still I don't remember the whole chemical reaction. We'll check back. But there are still production of CO2 from the conversion, so which is not good. And geothermal energy. So geothermal energy is not something that you can obtain everywhere, because, for example, in Iceland, they have a lot of these geothermal. So it is because of their geographical area, so they have this geothermal. And wind energy also is not really, it's not in Malaysia. I don't know if you ask why, but if you go to somewhere with the when the land is actually clear of forests, is like I went to Scotland. There's a lot of wind energy, wind turbine, that can generate electrical power. So in Malaysia, solar energy is the main, because we are getting sunlight throughout the year. All right, so that one is actually very good to utilize. And we also have resources like a river that can generate hydropower. Right. Oh, it's a bit okay. So energy consumption, this is the reference site of 2023. We still look at still is it is petroleum based fossil fuel, the biggest, right? And I think it's the biggest, yeah. Okay. Secondly is the coal. Okay, coal mining is from coal, but Malaysia does not have coal, but I think US. And then natural gases. Of course, when you have fossil fuel, you also have natural gases. All right, natural gas resources. So you can see that the portion that contributes the CO2 is still the biggest, yeah? 31.7, 26.5. And I cannot see this one. Is still the biggest portion compared to the nuclear energy, hydroelectric, and renewables. Renewables meaning that other than, for example, just now solar, we have hydrogen and so on. Okay, so we can still see that the usage of energy is still largely based on fossil fuel and coal. So these are all natural gas. These are all CO2 contributing activities, and we cannot help it. We still rely a lot on these resources. Okay. All right. Next one, the market. Okay. So since is the whole wide world talking about alternative energy, alternative, renewable, green energy. So it's a new market. Okay. So we can see that the market is getting higher. So it is expected from this market study that the business in energy, renewable energy, green energy is expected to be around 1.5 billion in 2032. So this gives out some opportunities to for business and for job applications. Okay, we probably before the production of solar polysilicon solar cell largely is imported. No, yeah, imported from China. Okay, there's a lot polysilicon solar cell from China, and the biggest producer. All right, so that is sort of a new business, especially in Malaysia. If you browse through, there's a lot of companies doing solar installation. Okay, I'm thinking about installing solar, but it has we have to put a lot of money for to set up. Okay, because my electricity bill is 1,000 above, so I have to put in a lot of money to invest on solar. So that's one thing. Even though they say that the polysilicon, the solar cell, the is cheap, but relatively in Malaysia, it is still considered expensive. Okay. So with this renewable energy, we is an alternative effort. Is a good effort to reduce effect of high carbon emission, especially CO2. And this is a growing technology advances. Okay, so let's talk about this renewable energy market, the key players. So I don't know where these companies are from. Okay, they actually uh, scattered. Okay, but in terms of technology, um, Malaysia is still not the manufacturer, but we are still the users. So we don't yet innovate the the technology, but we're still the one who use. Huh? All right. So probably one day some of us will become a dominant or a significant energy player. Hopefully, Malaysia will become a dominant energy player. As like we are now quite dominant in chip producing, chip producer, as chip producer. All right. So this is just giving you ideas about a new horizon of energy, which is renewable energy or green energy in this case. Yeah. Right. And among this renewable energy, we can see that solar, which is here, this is total. This is here photovoltaic means that solar, which is photovoltaic cell with a polysilicon solar cell, is expected to account for 60% of the increase in global renewable capacity, which is good for us because as countries with a lot of sunlight, we have this advantage. Yeah? So you can try to look at this reference to find out about the solar. So wind, as I told you, I don't know why we are not utilizing wind, but since we have a lot of forests and it requires an empty space so that the wind turbine can be put there. So I don't know, probably we don't have that capacity. Hydro and bioenergy. So bioenergy is still very less, much less being utilized. So these are the success stories of renewable energy. So Iceland, this is the wind turbine. If you look at here, it requires empty space like this. So I don't think we might have this on top of mountains, but to build all this, because it's very tall. Uh, so I think there's one island that has this wind turbine in Malaysia, but not many. I don't see this much in Malaysia. But Iceland, because they have this geothermal, as I mentioned just now, they have this geographical location, so they have this geothermal energy production. Okay, and because they are small, yeah, they are small country, so they run almost entirely on renewable energy. Okay. Uh, there is also in Germany, they working very hard, like replacing the train railway with the polysilicon, so that they can generate solar energy from solar, just by using the railway where the train pass by, and some are actually putting in on roads so that they can generate electric from the solar cells, not just on our on top of our house, or no, they put it on railway, on roads. Okay. I'm not so sure uh, how much they have switched from fossil fuel to renewables. And also this Costa Rica, probably you can read about this. Yeah. So there are other issues regarding renewable energy, especially when we talk about solar, or later we'll talk about hydrogen energy, is storage. Okay, because we understood solar can only be utilized during daytime. And then what about at night? Or what about during, it's cloudy most of the time? Okay, so we need a mechanism to store the energy. Okay, so the technology in battery development is very important. So some of you might, I don't know, drive EV, electric vehicle. So before this, the battery technology is not that good. Yeah, you cannot drive long far before you need to recharge the battery, or the battery lifetime is not that good. So the battery innovation now probably is much better, but still there are a lot of room for improvement. Okay, so in battery, the storage capacity is very important, how much it can store and how long it can be used, because to replace the battery is very expensive. I don't have EV, I don't have electric vehicles, so I don't know the cost of the battery. Okay. So Denmark, okay, Scandinavian countries, they are quite advanced in this renewable energy technology, or not to say technology, but they're passionate. They're passionate in replacing fossil fuel energy, so they insist on certain legislation. For example, they talk about wind power. So they have these wind farms and some policies on a replacement of energy from biofuel. So then Finland, Denmark, Germans, they are Iceland, so they are probably very good uh, example of looking how renewable energy being used to replace the fossil fuel energy. Okay, so as I mentioned, the issue is about storage. Okay, so the battery technology, I will try my best to discuss next week. Okay, because I'm not really an expert in batteries or in storage. Okay, energy storage. But the purpose of having to discuss about sustainable chemistry subject is to introduce to you all this sustainable chemistry, sustainable energy. But if you wish to know the deep chemistry behind the energy storage and whatnot is a different subject. Okay, and we also have to put some initiative like financial models. Like in Malaysia, we have sort of initiative that you get rebates from the government if you install solar. I also don't know how much now or how how's the rebates. So anyone have experience install solar at your home probably know better. Okay, so these are the overview of green energy. And it is very important to have the role of education to talk to people, especially laymen, about the importance of green energy. So educating the public on the importance of renewable energy. Advocacy is about policies, right? Education, okay? Teaching students at schools about the importance of green energy, sustainable initiative, and renewable energy advocacy, and individual responsibilities. This is something that we as individual can do. Okay, so to reduce our carbon footprints. So yeah, let's listen to you. Nadia, what is your contribution to reduce your carbon footprints? Can you answer? Nadia, you okay?
Uh, Carbon footprints. Maybe deleting my emails.
Oh, okay. Okay, so let's Shalini, can you speak or can you are you still somewhere else? Your mic is not working? Okay, what about Cheng Hao? What's your initiative, individual initiative to reduce carbon footprints?
Uh,
Yes, Cheng Hao.
me-
What do you understand about reducing carbon footprint? Okay, let's move to I can help me. No, this is personal practice.
I just minimize the usage of paper.
Okay, that's one thing.
Uh-huh.
Paperless, right?
Yes, more to digital.
Yeah, all right. So Hongyan, what's your right?
For me, I think I for the transportation I go to school by subway. Don't
All
buy car.
right, very good. Okay. Okay. Tiffany, what's your thinking about this?
When we finish use the light, we can quickly close.
All right.
Turn
Okay.
off.
Right. Okay. So I can see that you understand that your individual responsibilities, huh? To reduce the carbon footprints. Yes, we can do paperless. We can try to minimize the usage of energy, okay? And then if you can walk, I know that Malaysia is very hot, okay? Almost extreme nowadays. If you can walk instead of using cars, okay, they are still using petroleums, they're using biofuels, okay? So try our best to avoid these carbon footprints. You can think about also how to minimize energy. There's a lot actually. I always on the waste recycling. uh, I try I try my best to uh, bring my own container, recycles as long as I can, as much as I can. Okay, trying to sort the waste accordingly. So this one is a habit that we need to develop. Okay, when you need to print something, think about whether you need it or it's just a waste of carbon, or print your paper and the ink itself. And if you can walk, which is good for your health, try walking rather than using your car or your bike, okay, which is a small contribution from us. So we can do a lot of things to contribute with it is in this individual responsibility to help save the earth. Apart from that, getting involved in local green energy initiative, supporting local business that prioritize sustainability. So if we can find business that that prioritize sustainability instead of using plastic, they try to use renewable paper for the packaging. So we try to support them. Okay, local green energy probably I don't know, probably we have community that grows plants. So I can't think of the example right now, but we need to be, especially we in science who understand the issues of CO2 and understand the issues that the CO2 is actually contributing to the climate, the global warming, which end up one day we will have the impact. You can see the flooding and all that. This is also something that we can help to talk to people. Yeah, I need to show chat previews. Just a moment. Yeah, sorry, if I said issue. Okay. All right. Okay. So think about it, talk about it, and say to people, if you can, let us use our own food container, bring our own water, no plastics. You have to start with yourself and then your friends and then your families. Then we can try to make it a community action. Okay. So discuss ways business can engage employees in sustainable efforts. So now some of you are working in big companies and small companies. Then you can start the way of life of sustainable, more sustainable. So let us start that effort in your where you work, okay, your businesses, your office, okay. And then just now mentioned about using public transportation. There are those using electric, okay, which is better, supposed to be. Share examples of KPIs that can be used to measure the effectiveness. Okay, this one is more on bigger programs. Yeah. So let's start with the first one, solar energy. So this one is now getting more common. So solar photovoltaic cell, which is this one, PV, photovoltaic cells, solar cells. We can do plantation, we can plant, we can do the agriculture under the solar cell, and we can also use parking lot as to put the solar cell. So this one has been utilized in Malaysia. There's a lot already being utilized. Yeah, thank God that we have throughout the year sunlight, and we can utilize this. And as I mentioned, the issue is about energy storage. So why? Because the intermittency and the variability, which is it's not stable. So we need to store the energy in a battery or in a proper energy storage. Grid stability and reliability, because we cannot have unstable energy supply. We need a stable energy supply. So storing excess energy for later use. Okay, this is very important. So we will talk about energy storage, the chemistry of energy storage next lecture, just a bit. So how does photovoltaic cell work? Okay, so this is the photovoltaic cell. So it's just a simple explanation on semiconductor principle. I'm not an expert in semiconductor. So what happened is when it absorbs sunlight, okay, the sunlight hits the surface of solar panel. So the solar panel is based on polysilicon. It's made of semiconductor materials, usually silicon, which has the ability of to absorb light. Okay, and the energy from the absorbed photon, so we have discussed about photon in photochemistry, excites electron in the semiconductor, which is the silicon, causing them to break free from their atoms. Okay, so this creates electron hole pair. So you can see that the separation of electron and hole. Okay, so an electron is negatively charged and the hole is the absence of electron. That's why it is called hole, which can act as a positive charge. So it's not a entity like H plus or cation. It's just that when the electron move, then it leaves a hole and it can act as positive charge. So when this happens, the separation of electron and the production, the hole is there. The solar cell has an electric field due to the junction between the two layers of semiconductor materials. So, well, I'm not well versed on the p-type and n-type. So this electric field pushes the free electrons toward the n-type and holes toward the p-type, okay? So because of this movement, so we have this electric current generation, okay? So this is how we get the electrical power from solar cells. So this is very basic one that I'm telling you, the one that is basic. So it's not the, probably there are some other deeper, complicated explanation, but this is how it works, okay? But there are, of course, at this moment, we rely a lot on polysilicon, which is very big, very bulky. You can see the picture just now, okay? Still, it is heavy, very bulky, very big, okay? So you need to install, you need to have space to install. So now, right now, we can do this, okay? All right, but what if we have a better alternative, but still we can harvest the solar, okay? So at one time, the polysilicon market is hampered with COVID-19. So the production was like going down. Now it is recovering. So it is still the best option for solar cell. Okay. So what about other innovation in solar cell technology apart from polysilicon? So we have these perovskite solar cells, thin film solar cells, and of course, AI assisted for optimization of energy system. So these are among innovation in solar cells, and there are some additional that I can share with you. So perovskite solar cell, the principle is still the same. The electron will move, okay? So there is a separation of electron and leaving a hole, okay? So that process will end up generating current. So perovskite solar cells offer promising alternative with the potential for higher efficiency and lower production cost. So this is still at research stage. Okay, I don't know whether they are being applied in real setup, perovskite solar cell. So let's look at what is actually perovskite solar cell. But definitely here it is mentioned that it is lightweight. Okay. So perovskite is this, okay, a type of thin film solar cell that utilize a perovskite structure compound, typically a hybrid organic inorganic lead or tin halide. Okay, so they are metals, okay, halide, as the light absorbing layer. So this is where you put the perovskite. And then you can see that the same process, photon from sunlight and the separation of electron and holes happen. And this movement will generate electric. Okay, so these cells are attracting significant attention due to potential for high power conversion efficiency, meaning that the efficiency of converting photons from the sun to electrical power is efficient compared to the polysilicon just now, and relatively low production cost. But there are some hiccup here because it is metal, so there are some issues of toxicity. Okay, so perovskite have demonstrated impressive power conversion, means that the conversion just now that I'm talking about, they are thin film structure, much thinner than the polysilicon, that can be printed or coated. Okay, so now you can understand that the material can be printed on some other material or coated, making them potentially easier and cheaper to manufacture rather than the bulky polysilicon. And with adding to that, it has flexibility and transparency. So imagine that you can coat it on the window at the house. So instead of having the polysilicon at the top of your house, you can just coat on the window. So this will become, instead of traditional rooftop solar, you can have built-in integrated photovoltaics and wearable electronic, meaning that you can wear the solar cell together with your embedded in your clothes. Yeah? So again, this one is the same thing, charge separation, perovskite, okay? And the other one is a thin film solar cell. It's a second generation solar cell made by depositing one or more thin layers of photovoltaic material. Okay, so let's look at what photovoltaic material that is mentioned just now is this one. These are some of the chemicals that we can put on top of solid support. Okay, so cadmium telluride, copper, indium, gallium selenide, so amorphous silicon. So we can put this on top of film, so you have this flexible thin film solar cell. And the principle is the same. Once the photon bombard on these chemicals, they create the separation of holes and electron, and from there the generation of current. Okay, so this one you can see the flexibility, the thinness is much better. But what I heard from the fellow researchers who did this, the conversion efficiency is not that good yet. Okay, probably they need to study the optimum formulation. So the conversion right now, polysilicon is still the best. Okay. Right. The other one is quantum solar cells. So quantum dot solar cells. I think I have talked to you about carbon dots, yeah, in the photochemistry. So it works the same. Quantum dot and carbon dots, they can absorb energy, photon. Okay. And what happened is you can see it works like semiconductors as well, the separation of hole and energy. And quantum dots can be engineered. What does it mean is you can control the size. Okay, so quantum dots can be from the size of 40 nanometer down to 15 or below than 15 nanometer. So when we control the size, we can control the wavelength of the light absorbed by the quantum dots. So that's why quantum dots can be engineered to absorb particular wavelength because it depends on the size of the quantum dot. So this one is more refined. I mean, if you wish to absorb certain wavelength, you can get a certain size of quantum dot. Yeah. Flexible solar panels for wearable. This one is the application, just like the thin film. Okay, so you can have flexible, you can have wearable solar cells. Imagine that. You can just put it on your clothes just to charge your phone. Okay, so what is this is additional characteristic of quantum dots. Tunable absorption, just like I mentioned, it is according to size. If it is below 20 nanometer or below 10 nanometer, it absorbs different wavelength. If it is 14 nanometer size, it absorbs different wavelength. Okay. So multiple excitant generation. So this one, I don't know how to explain. Okay. But a single photon can generate multiple electron hole pairs. Okay, meaning that a single photon, you can do this a lot of separation between electron and hole. But this one, nobody has done it in our department. Like perovskite, if you know Dr. Tan Kaban, he's doing perovskite. Solar cell, thin film solar cell, we have Professor Zulkarnain, but this one, I don't know who is actually doing this. Okay. So how it works, similar, charge separation, electron and hole. Okay. The other one is dye sensitized solar cell. So just now we put quantum dots, so we can also put dye on top of the solar cell. By doing this, we increase the efficiency of the conversion of the energy from solar to electric. Why? Because dye. So I hope that you remember what we have learned in photochemistry, that certain structure like conjugated double bond. Okay, conjugated double bond. I have shown you the picture of conjugated double bond. That is able to absorb more energy compared to the single bond. Okay, because I mean, for certain compound to absorb energy, they need to have this delocalized electron. Okay, so this delocalized electron exists in that conjugated double bond. Okay, so some dye chemical compound has this conjugated double bond. So that's why dye can increase the efficiency of solar cell. Okay, so on top of the solar cell, we can put a layer of dye or a layer of quantum dots or carbon dots that can increase the efficiency of the solar cell. So this is what we need, okay, to have the dye assisted or dye sensitized solar cells. Okay, so this is the structure that we need. It is here. You need the electrodes, okay, which I don't want to explain because it is not really important covered in this subject. Yeah. So what is good thing about dye? Okay, we can use organic, meaning that naturally extracted dye. So from here you can see that this is bunga raya. Okay, all right, I don't know the name. Okay, so we can extract the dye, the natural dye, and we can use that to produce the dye sensitized solar cell. So you can see this is the electrode. FTO glass is electrode material. So you can put the organic dye, which is the blue one, and we can add more like more semiconductor based nanoparticles. Okay, and this will be a good dye sensitized solar cell. So this is all about solar cell, but innovation. Okay, instead of just polysilicon, we can have perovskite. Okay, material. So perovskite is basically, there are a lot of others, but lead or tin halide. Okay, we can use a thin film solar cell, and these are among the things being used as thin film solar cell. And we can sensitize the solar cell with quantum dots, carbon dots. And also we can sensitize, meaning that increase the efficiency also by putting dyes on top of solar cells. Okay, right. So I think we stop now. We can talk a bit on hydrogen energy during our 8 to 9 session. Okay, thank you. Right. I'll see you at 8. All right, everybody?
Okay.
All right. Okay, so I hope that at least all of you has understood some superficial or basic concepts on solar. Okay, number one at this moment as green renewable energy. So I'm describing a very basic chemistry process in terms of separation of electron and hole, okay, for solar cell, and that's how the solar energy is converted into electrical energy. So the conversion from solar into electrical energy is the innovation that is currently being improved as apart from the physical form and the flexibility of the solar cell. So another issue with polysilicon, okay? So you can see that the polysilicon is hard and bulky, very big. The disposal, because the polysilicon, the efficiency drops, meaning that down to it is no longer economical to be used after 10 years. Okay, so every 10 years or 15 years, you need to replace this polysilicon photovoltaic solar cell. And imagine that this one has to be disposed. Okay, all these bulky things has to be disposed. So remember that I mentioned about green solvent, ionic liquid. Okay, so there is an effort there is a research that has been done to recycle or trying to dissolve this polysilicon using ionic liquid. So we need to also remember this. That's why we need to innovate, okay? Because the secondary disposal, the disposal of polysilicon it is indeed an issue, okay? So that's why, so this is the basic of conversion from solar to electric energy. So that's why we need to innovate towards more lighter, more efficient and flexible solar cell. So we have perovskite, thin films, quantum dot sensitized solar cell, and dye sensitized solar cell. There are others as well, okay, that increase the efficiency of the solar cell, conversion from solar to electrical energy. Okay, so let's move to this is something that is sort of number one now in the world. People are talking about hydrogen energy. So what is hydrogen energy? Hydrogen energy refers to the use of hydrogen as a fuel or energy carrier. So it is considered a potential clean energy because when hydrogen is burned, it only produces water. Okay, so if you burn fossil fuel, you get CO2. So if you burn hydrogen, it produces water, H2O. So this one should be, it is considered a green energy, and it is now being the talk of worldwide. Okay, everyone is trying to do hydrogen energy technology. Okay, so there are a few technologies available in producing hydrogen. Okay, let's look at it. Number one is, okay, before that, we look at different types of hydrogen. Okay, different types of hydrogen fuel depends on how the hydrogen is produced. So the greenest, okay, the most sustainable, the most safe is what we call as green hydrogen. It is produced from water splitting. Okay, so if you remember the electrochemistry, the hydrolysis, okay, what do you call it? Electrolysis, the water is split into hydrogen and oxygen. So that's how we get hydrogen, green hydrogen. So water splitting. So water is renewable, and then you can get hydrogen as a fuel. So it should be, the whole thing is green. And there is what we call as blue hydrogen. So blue probably not that green, but it is renewable because we can get it from natural gas. The natural gas can break down into CO, carbon monoxide, and hydrogen as well. Yeah. So, but still, there is carbon. Yeah, even though it's CO or CO, there is contribution of uh, carbon. Yeah, carbon footprint. That's why it is not considered green. It is blue hydrogen. Still, it is a good production of hydrogen as a fuel. Then the blue hydrogen, it is considered a blue hydrogen. Okay, so here you can see this is less favored because the hydrogen, the CO2 is being released to the environment. So it is still hydrogen, but it is called gray hydrogen. So this one is something that we need to understand. When we talk about hydrogen energy, the production of hydrogen also, some are green, some are not that green. So depends on the process of producing hydrogen. So you can read more on this in energy education, yeah, encyclopedia. So this is the detail of the explanation. Gray hydrogen is hydrogen produced using fossil fuel. So still CO2 is being released. Blue hydrogen, still CO2 is released, but it is resolved using carbon capture storage. So the carbon, the CO2 is stored somewhere. It is not released to the environment. So it is better than the green hydrogen. Okay. And of course, the green hydrogen is from the water splitting. This one, also known as electrolysis, and requires an energy input. Of course, in order to split the water, we need to supply electric. So in order to get electric, we need to supply electric, water split, and then you get energy from hydrogen, which is not really economical process. It is in fact expensive process. So that's why people now, even talking about hydrogen, they go to blue and gray hydrogen. Okay. So this is the uh, the production of hydrogen from membrane. Yeah, it is using membrane technology. I don't know detail about this, okay, but you can see that uh, the hydrogen can generate the electron from here. So when we have electron movement, then we can generate electric current. Okay, so this is called membrane technology. I'm not well versed of how the usage of hydrogen in by using electrolyte membrane. Okay, the water splitting is of course quite simple to understand, but this one, the membrane, I'm not so sure. Yeah, okay. All right. So 6 reasons why hydrogen is a fuel of the future. Okay. When we burn hydrogen, there is no direct CO2 emission. Okay. When we burn hydrogen, water will be produced. So it's safe because H2O. Okay. That means by switching from fossil fuels to hydrogen in engines, gas turbine, boilers, okay, the creation of power and heat can be done without direct CO2 emission. Okay. So there is already hydrogen gas turbine, and for example, from Mitsubishi. So you can refer to this reference to look at the reasons, the 6 reasons why hydrogen is a fuel of the future. So hydrogen is supposed to be high energy density. It combusts quickly and at high temperature compared to fossil fuel. Yeah. So we can say it is clean. It gives out a high energy. Okay. Before this, it's too flammable. So, but now, people, the technology is much better on handling the flammability of the hydrogen. So that's why the hydrogen energy now can be controlled. Yeah. Before this, the flammability is an issue. Okay, it's too flammable. It's too fast. Okay, it combusts very quickly, and if it is not controlled, then it might be dangerous. Okay. The other one is the use of microalgae. So this is microalgae. This is from natural resources. Okay. So what microalgae can help is to break down wastewater or biomass into hydrogen. So the production of hydrogen comes from the breakdown of wastewater or biomass by using microalgae. But I'm not so sure whether it's efficient, how much can be produced, how much microalgae is needed to produce the hydrogen. So it is still at research stage. So hydrogen, like this, but it's to find pure hydrogen, okay? To make pure hydrogen, okay, this one we're not talking about pure hydrogen. Okay. So this is one alternative. And storage potential, okay, this one, as I mentioned, I will postpone it to next week on the storage, how we can store the energy. Okay, these are giving you some ideas of now that hydrogen energy is become very, very trendy and people talk about it. There's a lot of investment, okay, on hydrogen production. So if you are interested in business, so hydrogen is a new big business, yeah. So that will be hydrogen, okay. So the problems that needs to be mitigated is about how to produce green hydrogen, but less with cost effective, less expensive, because at this moment producing green hydrogen requires electricity, so it is still expensive. So they have come up with this electrolyte membrane. So I'm not so sure how this I'll try my best to get back to you next week. I need to ask some expertise on this membrane. And there is also research on uses of microalgae. But another one, let me show you that there are things that I have. Sure. Someone. Just a word. I tried to open my WhatsApp, but I didn't. Let me just share with you the WhatsApp. Okay. Sorry to use this. I cannot find the WhatsApp in my Google CHM. So I'm sending two pictures in through the WhatsApp group. Okay, one, what I would like to discuss. Hope that I could open my WhatsApp here. Cannot, then you just look at the WhatsApp in the group. The production of syngas. This is another usage of biomass conversion. I cannot open. It's okay. All right. Just continue with this. Okay. We can use biomass. Okay. You refer to the picture that saying syngas here. So the biomass you can burn the biomass and we can produce syngas, which is H2 plus CO. So this is also another production of hydrogen, yeah, apart from or the one that we have discussed. Okay, so the next energy is biomass energy. So we have discussed about solar, hydrogen, okay. So mass energy, biomass energy, sorry. So this is quite simple to understand. So biomass energy is a renewable energy source derived from organic matter. So if we look at here, if we have waste, in fact, waste from rubbish, from agriculture waste, and even from poops, yeah, can be burned and can produce energy. So it can be burned directly for heat, yeah, that's also energy, but it can also generate electricity. So you can read this in this link, education in energy. So biomass is a versatile energy source, okay? And the most important is it can be converted into electricity, okay? So biomass, of course, as I discussed just now, organic materials, woods residues, organic waste, even the rubbish that is actually dumped in the rubbish site area can be burned and produce energy. Okay, so fossil fuels are not considered biomass because they are formed over millions of years, because they are fossil fuel, which is many years ago, millions of years ago. So the biomass is in front of us, the existing right now. So what we can do for biomass is we can do direct combustion, just burn, and then which can be used for heating, or we can boil water with that burning process. We can boil water and generate steam. So that steam can do the work to produce electricity, to drive turbines for electricity. So imagine you burn the rubbish or organic matters, boil water, steam is produced, and that steam can drive turbine to produce electricity. So that is one way of utilizing biomass. Biomass can also be converted into biofuels, like ethanol or biodiesel, or syngas. Okay, the one that I have shared in the WhatsApp, the syngas, okay, H2 plus carbon monoxide. So the hydrogen gas can be used as a biofuel. Okay, so this is biomass. So there's a lot of resources for energy, but still this one is still producing carbon. Okay, so what's the advantage of biomass energy? Of course, it is renewable. It's actually free. You can just gather everything and burn it, but it's not really friendly to the environment. But probably it is considered under green energy because it is renewable. It is versatile. Okay, you can use it for heating, for electricity production. If sustainably managed, the carbon released during biomass combustion can be offset by absorbed by growing biomass. But the carbon absorbed by growing. I think what is meant here is whatever CO2 being released during the combustion is captured and recycled. So there is a lot of research now talking about carbon capture. So you burn the biomass, the carbon, CO2 is captured and recycled, converted into other things to be used. So that if you can do that, then the biomass energy should be green, okay? But if it is released to the environment, then it is no longer considered that green, okay? So biomass energy can utilize waste material, which is good because we can, meaning that is the waste can be used into something, can be changed into something useful for us, generate electricity, and the carbon capture, the CO2 can be converted into something else, okay? So that will reduce the landfill, okay, the rubbish area, the landfill. So the waste can become wealth, okay? So the term is waste to wealth, okay? This is something that we can do as a business. Disadvantage, of course, in order to burn the biomass, we need a large area. Large scale biomass production can compete with food crops for land, meaning, okay. I don't think so. This will be a competition because we have a lot of waste from agriculture, which is not utilized. So it's not a competitor with food crops. While potentially carbon neutral, biomass combustion can still reduce emissions. Okay, even though we capture the carbon, but it can still release emissions like particulates. Okay, the carbon soot, yeah, and the nitrogen oxides is still being released in the environment. So sustainable habit are crucial. Okay, whatever. The cost of biomass energy can vary depending on the type availability of the biomass. Okay, so this one is just all right. So I think that's all. Okay. Uh, there is another one that I'm sharing. Apart from the syngas picture, I share in the WhatsApp group. Okay. I cannot open my WhatsApp here. All right. You can see the fuel cell stack. So it's actually the membrane that I showed in the slide. Okay, I can open up the membrane. And you can also look at your WhatsApp. So this is much better explanation of how hydrogen fuel can be used to produce electrical current, okay, with the help of proton exchange membrane. So detail of the process is beyond my capability uh, to explain. All right. So meaning that this whole cell, okay, that I'm showing in the WhatsApp group, can be a portable. Okay, so producing current by hydrogen, okay, and oxygen from air. So this is still at research stage. Then I cannot explain more unless I can call up the expert in this membrane, yeah, producing. So, all right. I think that's all on green energy. Okay, so the biggest hurdles in energy is about how we store that. How can we store the energy? Okay, because it's not always a sustainable supply. Okay, like if it is solar, you can only get it in daytime. So what about nighttime? If you are at a very secluded area. So that's why energy storage technology is very important. Okay. So if we are talking about energy storage, we are talking about battery technology. So technology in battery. So I will try my best to discuss about battery technology. Next week will be a very short one. And I hope that this discussion has at least introduced you to the about the green energy alternative for instead of fossil fuel energy. Okay. So any questions? All right. So if there is no question, good night, everybody. Have a good rest. Bye-bye.
Thank you, Prof.
Goodbye, doctor.
Thank you,
Thank you.
doctor.